What motivates me about my job is that I contribute, in an indirect way toward those really large, significant scientific questions. So I'm not the scientist trying to understand, is there evidence of life in this rock? But my work on robotics helps enable that science. And for me, that's very rewarding and very motivating. The role that I played in Perseverance and Mars exploration in general has always been technology development. So I don't build the spacecraft that actually goes to Mars. I do research that enables new capabilities for those missions. And usually there's a span of time of 15 years or more between when you start the research on a new capability and when it first is actually used in a mission. So between the years 2000 and 2015, I did some of the early research that enabled several new capabilities for Perseverance, including a vision system for the lander to be able to land very precisely among obstacles, a new vision system for the rover to let it drive a lot faster. And then we have the first ever helicopter to go to another planet, a little helicopter called Ingenuity. And one of the inspirations for that was work I was doing for the Army on small drones for Army applications. So that actually began in my lab. The most intriguing part of Perseverance for me is that it's just the first step of what we hope will ultimately be bringing samples of Mars back to Earth. So NASA and the European Space Agency have an agreement to work toward what we call a Mars sample return campaign. So part of the mission of Perseverance is to pick up samples and store them in little sealed tubes on the ground on Mars. And if all goes well, we will send another mission in the coming decade that will pick up those samples and bring them back to Earth, where we can study them with much more sophisticated instruments than we can ever bring to Mars. And that's an important part of, trying to understand whether or not Mars ever held life. The 7 minutes of terror is the time from when the spacecraft first enters the atmosphere on Mars to when it touches down. Because that's the amount of time it takes to make that transit from the top of the atmosphere to the ground. And it's terrifying because we have no control. All we can do at that point, that's the most dangerous part of a mission. And all we can do is wait and listen to the signals and keep our fingers crossed and hope that all the work that went into it ends up in success. Well, my emotions when it landed successfully were, first, if we back up, that 7 minutes, I got really, really nervous. I had my fingers crossed that that lander vision system was going to work. And so I was actually pretty surprised at how nervous I got waiting for the end result. And then when it was successful, I was hugely relieved. Where next in solar system exploration? NASA and the rest of the world are exploring all over the solar system. So there's more work to do at Mars, but we now know that there are moons in the outer solar system that have liquid water oceans inside. And, still a big part of the question driving exploration is, could there be life anywhere else besides Earth? And so Jupiter has a moon called Europa that has a subsurface ocean. Saturn has a moon called Titan that has a subsurface ocean. And there are other moons out there like that. So, one of the new directions is to go and explore those moons with subsurface oceans.